5-3 exponential functions. So key features of f of x equals 2 to the x power. What does this graph look like? Again, you can make always a table. And for these, you can just use 3 points. I can do -1, 0, 1. So 2 to the first power, 2 to the negative first power. Remember, you can never have a negative exponent. So that would be 1/2, 1 over 2. To make that negative exponent positive, you do the reciprocal of 2. Then 2 to the 0 power, anything to the 0 power is 1. 2 to the first power is a 2. So this ordered pair here would be -1, 0.5, 0, 1, and 1, 2. So -1 and 0.5 would be right about here, 0, 1, and 1, 2. Now, exponential functions never cross, will never touch the x-axis or cross it, because there is no number that you can ever absolute value, that you can put 2 to whatever power will either ever equal a 0 or a negative number. So the graph of f of x, 2 to the x, gets infinitely close to the x-axis but will never reach it. So it does not have an x-intercept. So my domain here, again, my domain for any function would be all real numbers. My range for this exponential would be all values of y that are greater than 0, not equal to 0, again, because there's no number that you would ever be able to do 2 to that power, and that would give you a 0. So y would be greater than 0. My key features here, y-intercept, it touches the y-axis at 0, 1. X-intercept, there is none. And then this function is always increasing. 1/2, 1, 2. If I were to put 2, it would be 2 squared. It would be 4. So this function is always positive. So just to kind of go over what I just said, the graph of f of x equals to the x is continuous between and beyond the x value. So the domain is a real number. The function is increasing over its domain because it is defined by powers of a positive number. The function is always positive. The function gets closer and closer to the x-axis but never quite reaches it. So when a function approaches a line in this manner, the line is called an asymptote, and the equation of this asymptote is always y equals 0. And again, the range are all values of y greater than 0. So now identify the key features of the function f of x for when b equals 2, which we just did, and when b equals a 1/2. So now doing the exact same. So now 1/2 to the x powers. Again, I can use the exact same ordered pairs, same x's, -1, 0, 1, 1/2 to the negative first power. Remember, to get rid of the negative, you do the reciprocal of 1/2. So 2 to the first power equals a 2. Anything to the 0 power is always a 1. And 1/2 to the first power is a 1/2. So this ordered pair is -1, 2, 0, 1, and 1, 1/2, but in order to graph it, let's just put 0.5. So now I draw my graph. -1, 2, 0, 1, and 1.5. Again, it's never going to touch the x-axis, only gets very close to it. So my key features here, my domain is still all real numbers. My range, again, it's never going to hit the 0. It's never going to come down to the negative numbers. So y is still greater than, all values of y greater than 0. My y-intercept is 0, 1. My x-intercept is none. It will never touch the x-axis. And my asymptote is y equals 0, just like these. And notice how when a was greater than 1, your graph is still above the x-axis, but it's increasing here. And now this one, when your b value is less than 1, it's decreasing to 1.5. So this would always be decreasing here. Right here, a network administrator uses the function f of x equals 5 to the x power to model the number of computers a virus spreads to after x hours. If there are 1,000 computers on the network, about how many hours would it take for the virus to spread to the entire network? So here you have a table, and then you're trying to find out at what value for x would your f of x equal to 1,000. So it would be somewhere between 4 and 5. Again, you can then play around with your scientific calculator and try 5 to the 4.1 power. You can try 5 to the 4.2 power and see which one gets closest to about 1,000. And then this is what the graph would look like. So if you would keep on at 5 to the 4.3, that's when it would get close to about 1,000. If you would do that on a scientific calculator, 5, you would press Y to your X button, 4.3, and it equals to about 1,012.9, so that's when it got closest to 1,000. In about 4.3 hours, it would take the virus to spread to the entire network. So how long would it take for the virus to spread to 50,000 computers? Well, if we continue with our table, we had f of x equals 5 to the x power. Let's say I'm going to go with, let's try 7. If I do 5 to the 7th power, 5 power of 7 equals, that's about 78,125, so I went a little bit too high. 5 to the 6th power, 5 power of 6 equals about 15,625. So it has to be somewhere between a power of 6 and a power of 7. So let's say if I try 5.6.5, 5 y to the x, so this is just kind of like guess and check. It's about 34,939. So let's say if I do 5.5 to the 6.7, 5 y to the x, 6.7, that gives me about 48,206. So 6.8 would be too much. So it would be about, technically the real answer is about 5.6.73 if they really want to get technical with that. But I would take 5 to the 6.7 hours. All right, an exponential function. So this is the form for an exponential function, is the product of an initial amount. A is always your initial amount, and a constant ratio. B is your constant ratio raised to a power. B always has to be greater than 0, and it can never equal to a 1. And A is a non-zero constant. So here, what is a written form? So f of x equals a times b to the x power. What is the written form of a function represented by the table? So constant ratio is you're multiplying by the same number, like linear was adding by the same number. So 12 to 36, 36 to 108, 108 to 324. Each time it's being multiplied by 3. So my constant ratio is a 3. Now to find the initial amount, it's finding A. It's kind of like finding A in all the other forms. Pick an ordered pair. So I'm going to use 1 comma 12. So 12 is my f of x, and f of x. So 12 equals A, which is what I'm trying to find, times B, which is 3, to the x power, which is 1. 3 to the first power is 3, times A is 3A, and then divide. So my initial amount is 4. So now that I have my A and now that I have my B, I can write my exponential function. F of x equals 4 times 3 to the x power. You can also write it as 4 times 3 to the x. Either one. I just like to use my parentheses. Here, what is a written form represented by a graph? So again, this is going, look at your y-coordinates, 128, 64, 32, 8. So that tells you that's either going to be a decimal or a fraction. So 64 divided by 128, 1/2, 32. So you can also do a table if that helps you. So this is going down. So 64 divided by 128.5, 32, they're all by 1/2. And let's say if by accident you tell yourself, oh, it's 2 because you divided 128 by 64. 2, that means that your numbers are going up. That means the numbers would be increasing. These numbers are decreasing, so it has to be a fraction or decimal. So my constant ratio is a 1/2. Next, pick an ordered pair. I'm going to go with 0, 128. So again, using my exponential function, x0 is my x, 128 is my f of x. So f of x is 128, trying to find A. B is my 1/2 power, my 1/2 to the x power, which is 0. Anything to the 0 power is a 1 times A is A. So A equals to 128. So 0 is 128. Your y-intercept is also your initial amount. So sometimes on a graph you can already see that it's there. So f of x equals my initial amount, 128, times 1/2 to the x power. If you do have a fraction, do put it in parentheses, because like this, it just looks like the 1 has that power of x. So it's better to put parentheses when you have a fraction as your b. All right, so here, write an exponential function for each set of points, 12 to 48. These numbers are going up, so you are multiplying by a whole number. 12 to 48 times 4, just double check, 48 times 4 is 192, and 192 times 4 is 768. So for letter A, I know my B equals a 4. Next, pick an ordered pair.
Good morning. Will the following teachers please report to guidance for your conference?